Good morning, everybody. I'm John Maxwell, W0VG. Okay, unmute me. Good morning, everybody. John Maxwell, W0VG. And I'm here to talk about something near and dear to my heart, the Doppler Systems DDF7001 Doppler Direction Finder. And as you guys know, we've had a rash of problem children on the repeaters here in Colorado. And this is just one of many of these devices that we've started to use here to try to be able to solve some of the interference issues. And let me tell you, what you're about to see is a pretty amazing tool. If we want to switch over to Mark's camera here, we're going to look at what it looks like. Wait, they're telling me to wait. Got it? All right, so what we're looking at here is a complete Doppler DDF7001. This is the brain. It's Ethernet connected, and it can be connected to anything remotely as long as you can talk to the device remotely. This is the head, which is called an RF summer, S-U-M-M-E-R, summer. It takes the 4 antennas and converts those signals to a switched Doppler signal. Basically, it switches every antenna at 1 kilohertz. And then it takes that inside the RF unit. It takes that and superimposes what's coming in from the antennas, subtracts the Doppler from it, and whatever's left is the direction that the signal is pointing. It takes 4 antennas or 8 antennas to do this, but the mobile unit that we use, which is this very heavy-duty cast aluminum box with 4 antenna terminals on it, they're quarter wave, spaced at 17 inches. Now, you're asking, well, how does this thing actually do its job? Very well. Here is a Garmin GPS puck, which gives us dead reckoning. When the vehicle is moving, it knows that the vehicle is moving forward in this direction. All the antennas are left front, left rear, right rear, always laid out in the same direction on the vehicle. Because it knows what kind of receiver you're going to use, it knows to calibrate automatically based on the information from that receiver. Now, as we get into the presentation a little further here, you're going to see this thing actually work. And a quick little primer on Doppler is this device gives us the ability to do 10 millisecond readings on any RF signal coming in on pretty much any band from 0 megahertz all the way up through about 2 gigahertz. What's the bandwidth on that receiver? Does that go to 2 gig or is that 1.3 gig? So it requires a narrowband FM receiver or a wideband FM receiver, depending on what you're using. These are all switchable pretty much. The one that we use mostly is an AOR 8600, which is good from, I think it's HF to 2 gig. As long as you've got the correct antennas on it and they're oriented in a quarter wave spacing on the roof of your vehicle, you're good to go. They also make these things with outdoor antennas, and the one that you see on the screen right here is a 3-band antenna, which is 800, 450, and 150, but there's 8 separate arrays in this, so it just makes the resolution a little better. That unit there with 2 antennas on it is $16,000. That's just the antenna. That doesn't include any of the other Doppler hardware or the radio. It's a little crazy, but the Doppler Systems is the state of the art. There is nothing better. And if you're trying not to waste your time, this is definitely the solution for it. Doppler supplies a piece of software called Target Track, which you're going to see here shortly, that overlays the data from the Doppler with a map in real time, and you can network other devices in. It's very quick and very easy. If you're using fixed Dopplers, you're using this tool on the right here called MPT. And MPT, if you'll notice on the screen, there is a cal button. Let me see if I can point at it here, if I can figure out how to do that. It should, because it should be on my computer here. It should, because it's on my computer. No red dot. Back up. So you click the cal button, and you put in the azimuth to the device that you're looking at. So you got a known repeater. It's at a known azimuth from you. You click the cal button. It's done. This is only for fixed configurations that you need to worry about it. And once you calibrate it, you don't have to calibrate it again. It remembers that. In a mobile configuration with a known receiver, you never have to calibrate these things. They just do it automatically, which makes life a whole lot easier. It knows from the type of receiver that you have and from the dead reckoning on the GPS. It just knows which way the signals are coming from. This is really good for locating stuck transmitters, malicious interference, which we've used it a lot for recently. And what you're about to see is an example of how this works with fixed and mobile Dopplers in real time. Now, what you're going to see is, hopefully we'll have audio here. Are we going to get audio? I don't hear the audio. Let me see if it's turned on. Do you hear my audio? I can back it up. I've got the volume, I think the volume. I'm sending audio, I believe. Yeah, pretty sure. Not yet. I could probably do it the hard way, but then we'll lose the video. No audio coming? Sorry, guys. Nothing like doing this stuff live. I believe so. I can confirm that as soon as I figure out how to run the new PowerPoint. No. I think so. Try it. Doesn't want to let me. And I thought I was sending audio to it. No, we didn't test that. It should be starting audio right about now. Guess I could explain it the hard way. And we'll just put my mic next to it, or a mic. Just restart the slide. There's a mic laying back there. Oh, you got it. Okay, what you're hearing is a playback in real time. This is the first transmitter. And you're about to see the second transmitter. There's the second transmitter. And you'll notice, well, come back here. You'll notice that when this is running, the interesting part about what it's actually doing is it's showing you a green ring around the predicted location of that transmitter. The black dots in the middle are the instantaneous calculations of where that is. And if you'll notice, this is going to put you within a good block of where the transmitters are. This is with 3 of these units. Currently, we have 4, I believe. And I mean, this is truly real time. You can't hide anymore. And if these guys that are out there jamming had any concept that, you know, this is consumer grade stuff. The FCC is running hundreds of thousands of dollars worth of hardware. Now this is a bit different than what you can get for ham grade devices. Ham grade devices, although they work, they're not networkable. They are not in such a configuration that we could take 6 of these direction finders, set them up, and display that information correlated in real time on a map. Now that we're able to do that, it makes this stuff trivial. And what the intent of what I'm trying to show today is, with a little bit of money and a little bit of time, this stuff is instantaneous. If we want to go look at the world and see where these problems are, we camp on a frequency. We set all of the direction finders remotely with this software. They follow. If you set it to a specific frequency, all of the direction finders networked in your device are going to follow. And if you change frequency, we can set a scan list up in this device that it will follow wherever that happens to be. And it will plot this information in real time and record it for purposes to be used at a later date. They call it evidence. And it is. It's damning evidence. If you've got a recording of what's going on, this is the device that you should be using. And we're starting to deploy these things. They're a bit expensive. The hardware that you see right there is probably about $4,500. Pretty close. One of those devices is about $4,500. But our time is worth a lot more than that. And when they call us and say that we have an interferer on blah frequency, being able to sit at your easy chair, turn this stuff on, and find it within seconds is a really, really beneficial tool. That's all I really wanted to go into. I wanted to make it short and sweet, so who's up next?